A very good morning all of you. In the last lecture we have seen basic encoders, and we also discussed the problem with the basic encoders where your priority is not defined. Like when you have more than one input enabled, your output is very random. To overcome this problem you are going to use the priority encoders. So till now we have discussed what is meant by encoder, and we have seen different encoder circuit like octal to binary and decimal to BCD encoders. But there is a problem in the encoders. The problem is very simple. So there is a problem in the encoders. If you take a general encoders, you are going to encounter one problem. So as I said, the rule for the encoder is only one input should be activated at a time. This is the condition we imposed on all the encoders, but in real time we cannot impose such conditions. Suppose let's take a simple keyboard, your alphabets keyboard or your numerals keyboard. When you type, there is a possibility that more than one key press. Suppose you want to press 9, you may press 8 or 9 or maybe 7, which are nearby to the 9. So that means there is a probability that more than one input is activated in a time in the encoder circuit. To avoid this problem, when you have more than one input is enabled, we are going to design a new encoder that is called priority encoder. So in priority encoder, what we are going to do is, we are going to do a simple modification. We are going to define the priority for each input. We are going to define the priority for each input. That means you are going to define which input is having higher priority and which input having lower priority. In most of the cases, the large magnitude input will have higher priority. Large magnitude higher priority compared to the lower magnitudes. So if you want to understand in simple terms, when you have a 0 to 9 decimal numbers, for the conversion into, suppose let's say I have an encoder which is going to convert your decimal numbers into, let's say, BCD. So in such encoder, your 9 having higher priority, we are going to define highest priority for 9 and lowest priority for 0, and remaining things will between 9 to 0. After 9, 8 will have highest priority. After 8, 7 will have highest priority compared with the other bits. This is how we are going to define priority for the each input, so that whenever more than one input is enabled, suppose let's take in this case, suppose 9 and 8 are activated at the same time. Since 9 is having highest priority, 9 will be displayed at the output side. Similarly, if you have 8 and 7, in this case 8 has highest priority compared to 7, so 8 will be displayed. Similarly, if you take 6 and 5, in this case 6 has highest priority. Even though 5 and 6 are pressed, you are going to get output only 6. So based on the priority, your circuit will decide which output is supposed to be produced with respect to the input side. So this is how your priority encoder going to encode the given inputs. To understand it, we will make a simple 4 input encoder with priority and without priority. First we will try with without priority. Let's take 422 encoder without priority. So this is the simplest circuit one can understand first. So that means you are going to have 4 inputs and 2 outputs. So we can also say this is nothing but you are going to give decimal numbers 0 to 3. It is going to produce a binary equivalent of 0 to 3 right from 00 to 11. So your 4 into 2 encoder will going to take decimal number 0 to 3 and produce binary equivalent of 0 0 to 1 1. So if I write D0, D1, D2 and D3, these are my input lines, and I'm supposed to have my output lines as B and A. So if I press D0, rest all are zeros. In this case I'm going to get 0 0. If I press D1, then I'm going to get 0 1. If I press 2, I'm going to get 1 0. If I press 3, I'm going to get 1 1. So if I write expression for A will be D1 plus D3, and your B will be D2 plus D3. That means you are going to have a circuit something like this: D0, D1, D2 and D3, and you are going to have 2 OR gates. So for the first OR gate, I'm going to connect D1 and D3. Second OR gate, I'm going to connect D2 and D3. So this is my A and this is my B. So now this is your 4 into 2 encoder. So whenever you press, when you press D0, it's going to produce 0 0 because nothing is active. When you press D1, it is going to produce 1 here and rest will be 0. If you press D2, it is going to produce 1 here, rest will be zeros. If you produce D3, it is connected here as well as here, so you are going to get 1 1 output. So this is how your 4 into 2 or 4 line to 2 line encoder works. This entire thing will be in the box. If you look at here, sometimes system may confuse whether input is given or not to the system. In that case, what you do is we can add one more gate here, that is a OR gate. This OR gate name is called valid input. What we are going to do, we are going to connect all the inputs to this gate. You are going to connect your D0, your D1, then D2 and D3. So if you look at here, you are going to take valid output as D0 plus D1 plus D2 plus D3. Your valid output is 1 whenever one input is activated. Similarly, if valid is 0, your valid output will be 0 when no input is activated. So that means with this valid output, you are going to see whether circuit has a valid input or not. Okay, so this is a 4 into 2 encoder without any priority. We are not assigned any priority. Suppose if I press D3 and D2 at the same time, your circuit will be in a metastable state where it cannot produce a desirable output. So now I am going to define my priority for this particular encoder. So now we'll try to see 422 priority encoder. So for this I'm going to define D3 as highest priority and my D0 as lowest priority, and remaining things will come in between. So this is a priority level decrement, or this is a priority level increment. So this is how I define my priority. Now I'm going to take D0, D1, D2 and D3. Now I'm going to have my outputs A, then B. I'm going to take one valid also. Suppose if none of the inputs are pressed, that means all zeros, none of the inputs are pressed, all the zeros, then in that case In that case you don't have to care the output, because you don't need that particular output. So you can valid output will be 0. It's clearly indicating that no input is activated. Now what I'm going to do is I'm going to first start with D3. Suppose if D3 is pressed, that means D3 has the highest priority. When D3 is pressed, it doesn't care whether other inputs are pressed or not. Suppose if D3 and D2 is pressed, I'm supposed to get D3 is my output. If I suppose D3 and D1 are pressed, I'm supposed to get D3 output. Similarly, if I press D3 and D0, I'm supposed to get D3 output. So when D3 is activated, when D3 is pressed, since I have highest priority, it doesn't care other inputs whether they are pressed or not. So I'm keeping a don't care. So you're going to get 1 1. So when D3 is pressed, you don't have to care about other input whether they are 0 or 1, because D3 has the highest priority, so it's supposed to produce 1 1 as output. Suppose if I want to press D2, in that case I don't have to consider D1 and D0, because when D2 has highest priority compared to D1 and D0, so when D2 is pressed, automatically it's supposed to produce 1 0, provided your D3 should be 0. Please remember, when you press D2, since D2 has highest priority, when D3 is 0, please remember, when D3 is 0, next priority goes to the D2 bit. So when D2 is pressed, you don't have to consider the D1 and D0, because D2 has the highest priority, is supposed to produce 1 0. Similarly, if I press D1, provided your D3 and D2 are not pressed, in this case I don't have to consider the you don't have to consider the D0, whether D0 pressed or not. You are going to get 0 1. Similarly, if D0 is pressed, so that means in this case going to produce both the zeros. In this is how you define the priority. Now I'm going to show you in a simplest way. So if D3 is pressed, you don't have to consider other input whether they are activated or not. You are going to produce a binary equivalent of 3. When D2 is pressed, provided your D3 is not pressed, in that case it doesn't have to care about the D0 and D1. It will just produce the 1 0 as output. Similarly, when D1 is pressed, you don't have to consider the D0, provided your higher priority inputs are at 0. So you're going to get the 0 1. So if you look at the valid output, in this case your valid output is 1, here also 1, here also 1, here also 1, because in all the 4 cases you have pressed one of the input number. Now I'm going to make one circuit for B and one circuit for A, so that I can get my priority circuit, a priority encoder circuit. So to do that, what I'm going to take a K map. So since I have a 4 variable, I'm supposed to take a 4 variable K map. One for A, one for B. First we'll start with B. So please listen carefully. There is a important point in filling the K map here, because when you want to form the K map, you have to consider all possible combinations. So I'm going to take my D3 here, D2 here, D3 D2 bar, D3 bar D2, then D3 D2, then D3 D2 bar, then it will be D1 D0, D1 bar D0 bar, then D1 bar D0, D1 D0 and D1 D0 bar. So if I take 0 0, you don't have to consider, this is the output is don't care, so you don't have to fill this one. And if you take 0 0, you're going to get this. I'm filling for B, so I'm filling for B. That means when 0 0 1, that means you're going to produce the output 0. And if you next one 0 0, so if you look at this term, so it has all the possible combination. 1x means 1 0, 1x means you can replace this 1x with 1 0 1 1. So that means you are going to have 0 0 1 0 0 0 1 1. For those things you are supposed to get output as 0. That means you are going to have this also 0 and this also 0. So it is 0 0 1 0. That means 2. 0 0 1 1 means 3. So you got the outputs. Now if you take the next one, so it like 0 1 XX. That means this XX can be replaced by 0 0 0 1 1 0 1 1. That means you are going to have 1 0 0 1 0 1 1 1 0 and 1 1 1. So this will be 4 5 6 and 7. For this you are going to have output 1. That means you are going to have 4 5 6 and 7. Output is 1. If you take the last one, that is, if you take the last one, 1XX means, so you can take 1 with triplex will be 0 0 0 0 1 0 1 0 till 15. That means all these 8 possible combinations, your output is 1. That means you are going to have 1 1 1 1 1 1 1. So getting my point? If you take one triplex, I am taking all the possible combination of triplex. It can be all zeros, it can be all ones, it can be 0 0 1, all the combinations along with this one. So for all these combinations you consider output as 1 for the B bit. Now this is your K map. Now I can form 2 octets. This is one octet and this is another octet. You don't have to consider don't care output here because it's not going to reduce the expression. So if you write expression for B, so you're going to write D2. In this case it will be D2. In this case it will be D3. So this is the output expression for B. Similarly, if you write it for A, so I'm going to take one more K map. So I'm going to fill my A inputs. So first case it is don't care. I can fill this as don't care. Next 0 0 1 will be 0 and next we'll have a 0 0 1 x. That means your 0 0 1 0 0 0 1 1. That means your 2 and 3 output will be 1. That means this will be 1 1. Next 0 1 0 0 0 1 double x means you can have 1 0 0 0 1 1 0 1 1. For all those combinations you are going to have output 0. That means you are going to have output 0 0 0. And if you look at rest all are 1s. If you look at here, for all other combinations of 1 followed by this one, you are going to have 1 output. That means you are going to have 1 1 1 1 1 1 1. So you can form 1 octet and 1 quad. So in this case I am going to get my expression as A equals, for this quad I am going to get D3. For this quad I am going to have D2 bar times D1. So this is my expression. If I write for valid will be D0 plus D1 plus D2 plus D3. So now I am going to construct a circuit with a priority. So now we got our outputs. Now we'll try to draw the circuit by taking D0, D1, D2 and D3. Now let's take one OR gate for here A and one OR gate for B and one OR gate for valid. So for A I am supposed to take D3, then D2 bar with D1 So this is your A input. This is nothing but D3 plus D2 bar into D1, and my B3 is D3 plus D2. So I'm going to take D2. So this is my D3 and D2, and I'm going to take all the inputs D0, D1, D2, D3 for valid. So this is my total circuit which will be in the box. This is your 4-bit priority encoder. Now I'm going to show you how this encoder going to give the priority, how it's going to work. Let's take case 1. In case 1, let us assume D3 and D2 are pressed. That means both are 1 1. Both are pressed at the same time. In this case, your D3 is 1, D2 is 1. So you're going to get D3 1 here, D2 bar will be 0, this also 0, 0 0 will be 0, 0 plus 1 will be 1, and D3 is 1, D2 also 1, you are going to get 1. That means you are going to produce output 1 1, which is output of D3 input. That means when you press D3 and D2, it is still producing 1 1 output. This related to the D3 input. That's how your priority has decided. Now I'll take the case 2. Let's take D2 and D1 are pressed at the same time. So that means D2 is 1, D1 also 1. If you look at in that context, your D2 becomes 0 here, and D1 is 1, 1 into 0 will be 0. Now this is 0, and if you look at here, your D1 is 1, D2 is 1, but D3 is 0. That means you are going to have 0 here now. 0 plus 0 will be, you are going to have 0 here, and D3 is 1, D3 is 0 now, and D2 is 1 now. You are going to get output 1. That means you are going to get output 1 0. So which is nothing but your D2 input. So that means even though if you pressed both D2 and D1, still your output is D2. So this is how your 4 input priority encoder gives highest priority to D3, then D2, then D1. Now we'll try to see. Now let us simulate the 4-bit priority encoder, in which I have given D3 as a higher priority. Next higher priority will be D2, next will be D1, next will be D0 as discussed just now. Now we'll try to test our simulation. If you look at it, there is a extra output called valid input. This input will be 1 whenever one of the input is pressed, otherwise it produces 0. That means none of the inputs are pressed, none of the inputs are activated. So if you look at here, a valid input is 0. That means none of the inputs are pressed. The moment I press D0, it's showing that there is a valid input pressed. So the equivalent representation will be appear at the output side. If you look at here, your 0 representing 0 0, and 1 representing 0 1, and 2 representing 1 0, and 3 representing 1 1. So this is a general encoder, a general 4-bit encoder. Now we'll try to test the priority case. So if I press D3, you're going to get an output 1 1, irrespective of the lower order bits, even if they are on. If you look at here, I switched on almost all the other inputs are less than D3. Still you are able to see the output as 1 1, because you have given highest priority to D3. Suppose if I make D3 0, now the next priority goes to the D2. That means D2 will have the highest priority. In this case, even though D1 and D0 are activated, but still you can see 1 0 in the output side, because your D2 has a higher priority. If I switch off D2 also, now D1 will have the higher priority. So you are supposed to get output 0 1, irrespective whether D0 is 1 or 0. Okay, now we'll try to test when D3 is on. I can switch on D1, but still no change. I can switch on D2 alone, no change. D0, no change. So that's why your D3 has the highest priority, even though if there are other switches are enabled or pressed at the same time along with the D3. This is how your priority encoder will overcome the problem of more than one input is activated at the same time by defining the priority for the each input. Please remember, this priority can be defined depending on the user interest. Now let us see 8 input priority, and similar to your 4 input priority encoder. So we'll see 8 input priority encoder. So in this we are going to have total D0 to D7, and in this case I have defined my priority as D7 highest priority and D0 is the lowest priority. That means your priority is high for this and low for this. Anything in between, it will be a decreasing order, your priority. Okay, so that means whenever D7 input is pressed, whenever D7 input is pressed, it doesn't have to care about other inputs. It directly produces the corresponding output related to the D7. So let's take my A2, A1 and A0 are my 3 outputs. Now we'll start with D7 first. Now let's see, when D7 is pressed, that means D7 is 1. Since this D7 is the highest priority, it doesn't have to care about other inputs, whether they are on or off. It's supposed to produce 1, 1, 1 as output. And similarly, when D6 is pressed, so since when D7 is 0, when D7 is not pressed, when D6 is pressed, and the next highest priority is D6, now it doesn't have to care about other inputs which are lower than D6. In this case, you are going to get 1, 1, 0. Similarly, when D7 and D6 are 0 and D5 is pressed, in this case, it doesn't have to care about the other inputs lower than D5, because the D5 has the highest priority. You are supposed to get 1, 0, 1. Similarly, if you having D7, D6, D5 is 0 and D4 is pressed, so D4 is highest priority now. Rest all are, you don't have to care, so you are going to get 1, 0, 0. Similarly, if till D4 are 0, your D3 is pressed. Now your D3 is highest priority and you don't have to care about other inputs. So in this case, it will be 0, 1, 1. Similarly, when D2 is pressed, you are going to don't have to care about your, so you are going to get 0, 1, 0. And next will be 1 and you have to take the don't care, that will be 0, 0, 1. And next will be your D0 is pressed, and D0 is pressed, it just produces 0, 0, 0. So this is how your priority encoder will produce output based on the which input has the highest priority. Let's start with a simple example. When D7, D6 are pressed, if you look at here, when D7, D6 are pressed, you have a D7 highest priority, it's supposed to produce all ones. Similarly, when D6, D5 are pressed, since D6 highest priority, your D6 will be appeared at the output side, and it goes on. So now we'll try to construct the circuit for A1, A2 and A3. Now we'll construct the circuit for A1, A2. Now we will construct the circuit for A0, A1 and A2. Let's start with A2. If you look at here, A2 is 1 at 4 places, that is D4, D5, D6 and D7. Since we have defined the priority, now we cannot take only just like D4, D5, D6, D7. So your D7 is the highest priority, you can write it as it is. But D6 you have to write D6 into D7 bar. Then only you get the priority for D6. When D7 0, only you get the D6 priority. Similarly, when you take D5, you write D5, D6 bar and D7 bar. Similarly, when you write D4, D4 into D5, D6 and D7 prime. So this is your 8 output. Similarly, you can write for A1 and A0. Similarly, we can write for A1 and A0 also. For A1, you have to consider D3, D2, D3, D6 and D7. For A0 you have to consider D1, D3, D5 and D7. Only thing is, wherever you have a particular data bit and other data bit should be in the complementary form. Let's take, so if we take D3, D3 is nothing but D3 into D4 bar, D5 bar, D6 bar and D7 bar. Similarly, your D3 is, your D2 is nothing but D2 into D3 bar, D4 bar, D5 bar, D6 bar and D7 bar. So on, you are supposed to substitute your D bits in both A1 and A0. You are going to get expression for A1 and A0 also. So we are going to have IC for this. For 8 input priority encoder, 8 input priority encoder, we have an IC 74148. So it is going to have total 8 inputs. Your D0 to D7, and you are going to have 3 outputs. Your A0, A1 and A2. This is your IC 74148 priority encoder. Now let us simulate the priority encoder, 8 input priority encoder. If you look at here, this is your IC 74148, which is a 8 to 3 encoder. That means it can convert octal numbers to binary equivalent number. At the same time, it also acts as a priority encoder. So my D0 to D7 are my octal numbers, or maybe 7, 8 inputs, and this is enabled for the circuit. If you look at here, all are active low inputs. That means whenever input is 0, that particular line is activated, that particular input is activated. Whenever it is at 1 means that is not activated. We have active low outputs. That means whenever light is not on means that particular line is activated, that particular output is activated. Whenever it is glowing, that means that's not activated, since it's a active low outputs. The rest two outputs will be used for the whether any input bit is pressed or not, and other one will be used for the cascading purpose. Now we'll try to run the simulation, try to see. These are my input lines, or these are my octal numbers 0 to 7. We'll make it all 1, because as per the definition, as per the IC concern, you are supposed to have a active low input, then only your particular line will be activated. Now all are 1. That means none of the input is activated. So first we'll test the octal to binary encoding application. Now we'll try to run the simulation. If you look at here, all the 8 inputs are at a high level. High, that means none of the input is activated. If you look at here, all are glowing, that means all are zeros, because it's active low output, so all are 0. If you look at here, this X4 will give you indication that whether any input is activated or not. The moment if I press 7 to low, that means 7th line is activated. If you look at here, when the 7th line is activated, 7th input is pressed. If you look at here, this X4 becomes 1, that means one of the input is activated. That means circuit has a valid input. If I make it 0, you can see here this becoming 0, that means none of the inputs are activated. So if I press 7, if you look at here, it is showing all 7 because it is active low. If they are not glowing means all are 1. This is 1, this is 1, this is 1. If I make it 6, 1 1 0, then 5 1 0 1, then 4 1 0 0, then 3 0 1 1, then 2 0 1 0, then 1 0 0 1 and 0, all zeros. Okay, so this is how you can use this 74148 for octal to binary encoder. At the same time, you can also use for the priority application or priority encoding. Let's see the priority application now. If I press 7th or D7 is usually your number with higher magnitude. Usually the number with highest magnitude will have the higher priority in general. In this case, I have defined higher priority for D7 and lower priority for the D0. So if I press D7, since D7 is the highest priority, even if you press other inputs, let's make it 6-1, no effect on the output. If you look at it, these are ones, all ones. If I change 6, nothing is getting changed. If I change 5, nothing is changed. 4, nothing is changed. 3, nothing is changed, because your D7 is the highest priority. Even other inputs are pressed along with D7, still it is showing D7 output only. The 7 equivalent binary number is showing. So if I switch off my D7 and switch on D6, now D6 is the highest priority since D7 is 0. In this case, even if you press D5, D4, D3 or D2, still your output will be 110 because your D6 is the highest priority. If I make both D7 and D6 0, and if I press D5, now D5 is the highest priority since D6 and D7 are off. So even if you press D4, nothing going to happen. D3, nothing going to happen. D2, nothing going to happen, because your D5 has the highest priority, that is 1001. Okay. Similarly, if I make D5 also 0, that means now your D4 will have the highest priority. When D4 is enabled, even if you press other input lower than D4, still it's not going to affect your output. So if I make all activated, let's take one more case. Now all are activated. Since D7 is activated, your D7 output will appear because your D7 is the highest priority. When D7 is off, it goes to 6 because D6 is the highest priority. If I switch off D6, and priority goes to D5, and if I switch off D5, then goes to D4. If I switch off D4, then goes to D3. If I switch off D2, and goes to D1. So this is how your priority encoder will encode depending upon how your priority is defined. Usually it is defined in a sequential fashion, with highest magnitude will have the higher priority and lowest magnitude as the least priority. This is all about your 823 priority encoder. In the next lecture we will see the decoders. Thank you all.